Great. So I think we'll start there. Thanks very much to everyone who's joined this session. So my name's Katie Mead. I'm an international recruitment officer in the Faculty of Science and Engineering, and I have Dr. Alpa Selic and Dr. Yu Ying Chang with us, who's going to talk through both the undergraduate and the postgraduate courses available in aerospace engineering. Just a bit of housekeeping. So if you've got any questions, please put them on the Q&A. Ideally, refrain from putting any personal information on there or any student numbers and things like that. So we're just going to run through the information about the courses that we have, and then there'll be an opportunity at the end to ask questions. But you can ask questions at any point on the Q&A, and we'll either try and answer them on the Q&A functionality, or we'll answer them live at the end. Cool. So I'm just going to quickly, for those who aren't familiar, just to talk about Swansea University. So we're located in South Wales. We're about 3 hours from London by train, and we're a coastal city of about 250,000. So it's a very diverse, vibrant city, but we're also lucky enough to be right on the coast. So it's a nice mix of urban and coastal living if you're studying with us. So we've got two campuses. All our teaching pretty much is done on one of these campuses. So we have our original campus on the bottom left, which is on the beach, located within beautiful parklands, and that was founded in 1920. And kind of in contrast to that, where our aerospace engineering is taught in bottom right, is it was a £450 million investment in 2015. We've got some state-of-the-art teaching and research facilities. I think it's quite impressive when you come onto campus and you especially can see the aerospace engineering department. You can see we've got some of the best facilities and very hands-on learning on the campus there. And I'm sure the lecturers will talk about that in a bit more detail later on. So we are really proud of being a research intensive institution where we partner with our with industry partners to ensure that our students are going on to what they're upskilled to do what they want to do next. So I would say 93% or above of our graduates either go on to further studies or into graduate employment within 15 months of leaving the university. We've been ranked 25th in the UK overall by The Guardian recently, and 86% of our research quality has been classified as world leading or internationally excellent, and we're really proud of that. So I'll stop there and I'll hand over to Alpa first. So Alpa's going to talk about our undergraduate courses for aerospace, and I'll let you introduce yourself and share your screen. Cool. Yeah, we can see that.
Okay, can you hear me as well?
Yeah, we can hear you.
You can hear me and you can. Okay, there we go. So I'm assuming it's all fine. You can hear and see. So hello, my name is Alper Çelik and I'm a lecturer in Swansea University for the last 2 years. And my main expertise is experimental aerodynamics, and I'm also having this role of as an admin tutor. So I'm going to just quickly introduce you to the department and what we do here. So before going into that, I think we just first need to talk about why aerospace engineering matters. So this is just a small information there on the left in red. So in 2022, 3.7 billion passengers were flown across the globe. And if you just think about this, aerospace engineering, by just this civil aspect of it, it creates a huge job and industry across the globe. And if you just add everything else, like the indirect jobs, which will I show you a graph now, and all the other industries which are linked to aerospace, such as space industry or wind turbine industry, and all other industries like related to military, we are creating a huge job across the globe. So, for example, here you see a graph about how many millions of jobs we can create across. Still, I think it's about on the civil part of the aerospace engineering. You can see how many jobs directly or indirectly related to the aerospace engineering degrees. So it can be about airport operations, it can be about the civil airlines, air navigation. It can be about indirect jobs such as the fuels, aircraft suppliers, manufacturers, and like with the coming years, the industry is going towards hydrogen-fueled aircraft. There will be a huge infrastructure change, and there will be another huge amount of jobs created around hydrogen-powered aircraft. And it's infrastructure because now nowhere on Earth has an infrastructure for hydrogen airplanes, and we will need to create all this infrastructure from scratch. Okay, so when we think about aerospace engineering, many of you just think about most probably aeroplanes, and everything about what you see about an aeroplane, the design, the wings, the engines, are in the fields of aerospace engineering. But also, when you get an aerospace engineering degree, you can work in wind turbine industry or any other sustainable or green energy industry. Or as most of you guys, I'm assuming that you are aspiring to, you can work on any aspects of space industry. And all the, again, from design to materials to propulsion, it all falls into aerospace engineering degrees scope. Of course, many of the engineering concepts are nowadays interdisciplinary. So it's not only aerospace, but many engineering degrees come together and create this product. Okay, out of all the aerospace engineering degrees, why you should come to Swansea University? And we will talk about a few things here. First of all, we are very proud of our research, and Swansea is very strong in its engineering degree about research and teaching. So we are proud of our world-leading research, and we have a Rolls-Royce University Technology Center on campus. This is mostly about the materials, about the gas turbines, and this Rolls-Royce University of Technology Center is a partnership between University of Cambridge and University of Birmingham. And we are a part of this prestigious group where we create next generations of the material scientists. So this is also under aerospace engineering as well. Some of our colleagues work in this technology center. We are very proud of our research. So research excellence framework, I'm assuming that you are not familiar with this. In the UK, every 7 years, a third body evaluates your research quality. And it is happening every 7 years. So in the last round, in 2021, the output from Faculty of Engineering was 100% world leading and internationally excellent. And we are proud of this one as well. And as a well-established aerospace engineering department, we are working in collaboration with many big companies such as Airbus, BAE Systems, Embraer, and GE Aviation. And of course, all this research cannot be done alone. We have a huge number of postgraduate students, and we are doing this. This creates a critical mass to create this high-quality research, which we are proud of. So specifically about aerospace engineering again, so we are a part of UK Aerospace Research Consortium. So this is like 11 universities, prestigious universities, who leads the general research trends in the UK, and we are a part of it with other universities, which you can see on the screen. And also recently, we become a part of UK vertical lift network. When I say vertical lift, it is about helicopters or like future air taxis, which will, we assume it will fly from buildings to buildings. So all these are fall under the category of vertical lift. And we are a part of that network in the UK, so where we can have an influence on the research agenda or the policies. So there are a few examples on the slides now showing you what we do in the university. So for example, this first example is about flatback airfoils. this was done with Vestas. Vestas is a wind turbine company, and this is the wind tunnel we have here. So this is where I do my research. And here you just see, for example, a numerical simulation where we were trying to understand what happens if you have a flat back airfoil. Normally, you know, the airfoils have this very sharp trailing edge, the back, but this one we just chop it, make it blunt, and we're trying to understand how the flow structures change, and this is a simulation. Or there's another example from one of our colleagues. So our colleague is generally studying on hydrogen fuel, and this is again a simulation where you see a multi-phase flow or a flame kernel, so how the flame starts and how it evolves. In the department, we are also doing many research about space. So indeed, we see how much the students are they have this like tendency to study anything about space, and they want to work in space industry. So we are trying to improve our both curriculum and our connections about in the space industry as well. And we'll talk about this later. We are now opening 2 new space master's degrees. So we are doing our projects around space related subjects as well. We have some links with the industry as well. We are also doing some projects related to the European Space Agency, or we are a part of Center for Solar Energy as well. So when you come to Swansea, apart from our research, we will go to the teaching later. What we are proud of is our employability team as well. So when you come here, we will try to help you as much as possible to achieve your goals. If this is going to a job or a placement, you will have a huge number of people who will be here to make you ready for your interviews, to find a job, and or for a placement. So they can help you to prepare your CV. They can help you to have mock interviews. They can help you to just get a connection from other companies. So this is, I think, very important. When you come to a degree, you will just want to have those connections to get a job at the end of the day. Okay, so although this sometimes matters for some people and sometimes it doesn't, we need to talk about this because I'm assuming some of you will want to know about these things. So Swansea University last year in QS rankings, we ranked 307th. And as a department, so there is no aerospace engineering department specifically, but we have this engineering, mechanical, aeronautical, and manufacturing, and we are now a top 100 university in QS rankings for this. And also, I will just talk about a few national rankings. These are within the UK. And of course, as you will all know, all these rankings have lots of weight functions, and then everyone chooses whatever they want to show. And this is the case for us as well. I will say it up front. But if you just check those rankings yourself, you will see things are fluctuating. And I will say Swansea Aerospace is a top 10 aerospace engineering degree in the UK with different aspects. So, for example, we are third in the UK for research quality according to Complete University Guide in 2022. We are 16 student satisfaction in the same table, and we were 6th in the research rating from Times Good University Guide. And I think I have one more, and 10th in the UK for graduate prospects outcomes. Okay, so these are some numbers, so you can check all these things yourself as well. But I think the main idea is we are around the top 10 university. We are trying to improve things, but also, as I said, ranking tables, sometimes they have like different weighting functions, so you should be careful when you are checking those things. So one more thing, I think either you will come to Swansea or not, you should be going to a degree where you have an accreditation with the accreditation body. And our degrees are accredited by Royal Aeronautical Society, Institute of Mechanical Engineers, and engineering councils. And even if you come to Swansea or other universities, this is my suggestion, make sure that you will go for a course which is accredited. So what do we offer in Swansea? We offer 2 different courses. So we offer an MEng and a PEng. PEng is for 3 years and MEng is 4 years. In both of them, you can have a foundation year. You can come from a foundation path And for both of them, you can have a year in industry or a year abroad. So what we are trying to do in this degree, in the course, we are trying to give you, in general, I will say like three things. One, versatility. So you will learn about lots of different aspects of aerospace engineering. This will be aerodynamics, this will be fluid mechanics, materials, systems. You will learn about management, and then you will learn about some awareness. You will get some awareness about what aerospace engineers do, in which environment they work, what kind of regulations and rules do we follow, what kind of requirements needed for any product. And also you will get some theoretical and practical skills. And when you put all these things together, we will try to make you as good as possible so you can find a job as quick as possible, or you can just improve yourself in the field you want to improve. So this is our department, and here I am. So, and here is Yu Ying. So these are the people who will teach you if you come to Swansea. And you can see that many people have different areas of expertise. So we have people from computational fluid dynamics, like myself, experimental dynamicist. We have people from dynamics. We have people from rotorcraft. We have people from engineering mechanics design, etc. Okay. And this is how a at the end course looks like. So this is a little complicated, but I will walk you through, and you will see it's simple. So there are 3 columns here, and these 3 columns represent the years, and we have some rows here which represents the modules. So you can see in every year you have a green and a blue color. So the green colors are the first semesters, the blue colors are the second semesters. So in general, we have 10 credit modules. So in every semester you will have like around 5 to 6 modules. So in a year you will have around 12 modules. And some of these modules will be connected to each other, and you see those arrows. And we have a few modules which runs through the year, but most of the modules are per semester, and you will see that most of the, again, modules are related to each other. And it's a kind of, you start from scratch and you just build up towards the end. And in the 3rd year, so we have 3 branches that you can choose. You can go to a space stream, material stream, and computational stream. So in this, when you choose a stream, so you have this like specific areas that you want to learn more. So you can just choose one of them, and you can get optional modules that is under that stream. Okay, and this is how you are getting assessed. So you can see that from year 1 to, if you are doing a MEng year 4, or if you are doing a BEng from year 1 to year 3, you can see how your assessments are weighted. So the yellow color shows the courseworks, and the purple color shows the examination. You can see in the 1st year this is more coursework, but in the 2nd year, because we in 2nd year it's a kind of steps up, and then we try to give so much theoretical information in the 2nd year, so the examination is a little important there. But in 3rd year, again, most of the things are about group works and courseworks, and year 4 again is like similar, it's mostly the courseworks. And here in Swansea we have this exchange program with Texas A&M, though this is very competitive. So every year, out of the best students who applies, we choose 3 to 4 students and send them to Texas A&M. But as I said, it's very competitive, so we can't send everyone to A&M. But if you achieve well in your marks and if you apply, you have a chance to have a semester in Texas A&M. Okay, we also have integrated masters, MEng, and also we have a taught masters, MSc, and these are also accredited by both Institution of Mechanical Engineers and Royal Aeronautical Society. And you get, in both of them, you get taught modules, but in MSc you also do a research dissertation. And I think you can give more information about this, so I will skip this. So okay, what about the facilities and what we do in Swansea when we're training you? I think one of the most important part of our course is we have lots of hands-on experience. So normally in an open day, you will come and see all these facilities, but now I will just try to make it clear to you what we are doing here. So, okay, these are some facilities. This is the flight simulator. We have two of these. This is the wind tunnel facility, and this is I will talk about this later. This is a national lab, which is flying. You go into this and fly. But let's start from like beginning. So in the first year, when you come to Swansea, um, we take you guys and send you to Swansea Airport, and there you fly an aircraft with a pilot. So at some point, we give you the opportunity to control the aircraft. You have a feeling of what's happening. And then when you come back to university, you go onto flight simulator and use the simulator and now see the difference between the reality and the simulator, or how good the simulator is. So you have this understanding of what is happening in real life and what does simulators do. And in your second year, again, you go this time to Cardiff Airport. In Cardiff Airport, you are going to use a National Flying Laboratory Center, and you will get on the plane. The plane will do some weird movements flying around this path, and you'll be a test engineer and get some data. And then you will come back to university, again do the same thing in the simulator, and you will see what is going on and how it differs between two. Okay, this is one of the aspects about our practical jobs, practical part. So there are some softwares that you will use. So you have MATLAB, Simulink, SolidWorks. These are all in general engineering tools that you will learn either in one module or more than one modules. And we have lots of support for you guys when you come in, because we know that being in university is sometimes overwhelming, and sometimes you don't feel comfortable with everything you know. So sometimes you feel like your maths is not enough. Sometimes you feel like you need more help or support from people about science or about writing. So we have different cafes that you can just go. These are run by weekly. So you will have either a lecturer or a grad student there waiting for you. So you can just go and ask questions or ask help about maths, writing, science, etc. So let me check the time. Okay, so this again, a few things about what we do in practical aspects. So in your first year, you will design a glider, and the main aim will be that glider to take off nicely, and we will do all these things on the beach, which we have access to, which is great. So we are next to beach, and we can just use that as we like. And the aim of this thing is to have a glider which takes off nicely and possibly lands. To make sure that it works, we put an egg on it, and we ask you to have that egg not broken. But of course, in many cases, the eggs don't survive. This is how you start. And there's a good example. Let's see it as well. Okay. Of course, the egg won't survive it as well, but the takeoff was quite nice. And then in your third year, you will now start to design your own aircraft group. And our students come up with lots of nice ideas. They do their designs. When they do the designs, they also go to flight sim again, to simulator. Whatever they design, they upload those information to the simulator, and they see that if it is working or not, if it's flying or not. And there are lots of different designs about the spacecraft, etc. as well. And they can use these virtual tools that we have to understand if I'll just skip some of the parts. So you can use the virtual tools to understand what is going on. And you manufacture whatever you design in the lab. And then you go to beach again and you try to understand whatever you have done is working or not in real life. So here's an example. And this is a good example. Not many of them ends like this. Unfortunately, it was at the end. So you will see that. Well, it's great. It's great that you start from scratch and you do the calculations, go to flight sim manufacturer, and actually try to fly it. Okay, and also in your third year, all of you will do an individual research project. And here there are some examples of the titles of students, what they want. General students choose what they want to do. And if you don't want to decide what you want to do, we always have topics for students. But these are some examples of what our students did before. There are a few examples here. So this again from, because I'm the wind tunnel guy, I give examples about the wind tunnel all the time. So this is, for example, this is just showing you what a gust is. So when you have this airfoils here, it creates this sudden movement and it creates a disturbance in the flow. So one of the students' project was, this is in collaboration with a PhD student, of course. We didn't expect the student to do all of this thing, but what the student did, they tried to check what happens to an airfoil, how it reacts to that gust, that disturbance. If there is no control surface, this is an airfoil. I will just play it now. Oh, it doesn't work. That's sad. Okay, sorry for that. Okay, normally what you would see, the left-hand side, we just do the movement and it will get stabilized in maybe like 1 minute. But the right-hand side, because you have a flap here with an active control, you can just make this airfoil get stabilized after got hit by that disturbance, maybe in 2 seconds. Okay, this was the aim. And this is one of my students' projects. So he wanted to do a boundary layer control in front of an airfoil. So this is not done too much in this. There's not a proper literature about this. So he come up with this idea. He designed it. He made this nice CADs. And what we are doing here, having these different types of leading edges on the airfoil, and we are injecting some air on the wing and trying to see if we can improve the lift or delay the stall angle. So, and he actually manufactured it. As you can see, this is our lab. So he manufactured it, he put it in the wind tunnel, and we did some experiments. And indeed, results were quite promising. So what we are now, he wanted to continue his MSc here. So we are now doing an MSc with him, and we want to publish something out of this. Again, throughout your journey in Swansea, you will have some field trips to some of the companies around the UK. And I think that's all from me. And are we going to get questions now or later, Katie?
I think we'll do questions after Yu Ying's presented her slides. Yeah, I think that'll be a good chance. But if anyone's got any questions now, like please put them on to the Q&A, and I can help try and answer some of them live, some of them on there if I can. Otherwise, we'll do some questions at the end. But thanks for that, Alpha. That was really useful, and I think it's really good to see like how hands-on the experience is for our students. Cool. So Yu Ying, we'll hand over to you now. Thank you. We can see your screen. You're on mute.
Muted.
Okay. Hello. Is that working now? Yeah.
Yep. Yeah.
Okay. Thanks, Alpa. I think Alpa already gave us loads of information about general views regarding the aerospace programs and support activities that we can provide to the students. So I'm going to just use a couple of minutes to highlight the postgraduate programs in aerospace engineering. And you can see why you choose that for the postgraduate study. As Alpa already mentioned, we are very much research intensive environment, and we are 96 in the in the world research quality and ranking, and also we're basically 100% world leading and international excellent environment. And we know that when we try to go into the postgraduate study stage and research, and will be play a major roles in the studies. And apart from that, and we have a flexibility regarding the various of MSc programs and the variable programs and the variable intradate available and which you can choose. Also, we aim to provide aerospace industry readiness, which means, when you graduate or get the degree from Swansea University, and we aim to provide rigorous and systematic understanding of the field and equipment with all the industry needs. And basically, we hope you become a credible aerospace engineer from the day one when you leave Swansea University. And also, as Alpa already mentioned, you can see we pretty much 50% of examination and 50% of coursework, and all this coursework will provide some practical experiences and lots of employability opportunities. Okay, coming to as we said, we got a various of MSc programs in aerospace engineering. And now the first question is, as we got lots of options, which kind of a program to choose and which program is actually most suitable for me. And I divided our MSc programs in the 4 categories below. So the first one is MSc Aerospace Engineering. So basically, based on that name, and is provide genetic aerospace program covers the design, analysis, testing, flight, and operation of aeronautical vehicles. And we'll cover the program structure later on. But these programs is, we have both September intro and January intro available. And so in summary, if you're looking for the TOT-based MSc program and you didn't have a very specific targets like I want to do the space, or I want to do, the focus on the computational, or the MSc, genetic MSc aerospace engineering is your first option. And we do have 2 specific programs which is coming soon this September. And one is called MSc Sustainable Aviation, and the other is MSc Space Engineering. Both of them will be started this September. And they will officially open the application from May. But at the moment, you can, press this link and register your interest over there. So when the application is fully opened, and you'll get the email notification and then transfer, make a formal application. So the MSc Sustainable Aviation, based on his name, is a specific focus on the sustainable aviation design and manufacture, and we hope to addressing the advancements in the next generation net zero aircraft technologies. And another MSc program is specific for the space sector, and we hope you have a rigorous and systematic understanding of the space engineering design process of spacecraft. And apart from this, taught MSc programs, we do offer MSc by research in aerospace engineering. So the MSc by research is a research-focused program, and it has a very flexible entry date. And we have start dates, full start dates over the, basically each of the quarter of the year, and we'll have started in October, January, April, and July. So just to highlight something in the sustainable aviation, which will come in this September. So as we know that, all the aerospace industries is aiming to achieve net zero in the, 2050. And so basically this MSc in sustainable aviation, we try to aim the targets of the most advanced technologies to achieve sustainable aviation in the industries. And we do have a lot of compulsory modules. You can see lots of compulsory modules like advanced propulsion, sustainability and environment analysis, and also next generation sustainable aircraft technologies. And all the at least 3 modules will directly relevant to the sustainable technologies in the in aircraft industries. And finally, you will be able to choose 20 credits from the compulsory modules. So that is sustainable aviation. And another highlight will be the space engineering from this September. And you can see apart from the some genetic aerospace programs, and there are 4 very specific space related programs like launch vehicle system design, spacecraft structure design, power source for the for operation of spacecraft, and advanced space systems. All these 4 new modules is directly relevant to the space systems design, and also plus with the space communication like knowledge like RF and microwaves. And then you will be able to choose 20 credit from the optional modules as well. So these 2 will be the very specific, MSc programs focus on the next generation of, aviation or the space industries. And this is a current program for we are running for a couple of years and very successful the genetic aerospace engineering. And again, these programs will be running both September and January. You can choose which intro you will apply for. And finally, just summarize the MSc by research, because this MSc by research in aerospace engineering is quite different with the taught MSc programs. And based on, we can see this program is research focus, and there's no taught modules in this program, and there is only 1 research project over the year. And it's very similar to the PhD studies. Basically, you got the supervisor and the second supervisor, and then under the supervision of the academic staff, and you're going to spend the 1 year in Swansea University and focusing on a deep research project. And as we know, we have a world-leading technology which contributes to many exciting projects for the MSc research projects. And also not only in aerospace engineering, as we have a multidisciplinary in nature in Swansea University, so which means our research project will incorporating our strengths in research areas across all the engineering disciplines, and for example, the civils, computer science, and other disciplines as well. And we have extensive collaborations with international companies in aerospace industries and loads of research projects. And it's actually directly coming from the industry collaborations. And again, we have a very flexible entry date with the MSc research by research, and we're running 4 entry dates per year. So that's pretty much my short introduction to all MSc programs. And if you have further inquiries or have more details, please contact me. I'm the program director for all the postgraduate studies, and this is my email address. And please feel free to email me or ask any questions and in this section. Thank you.
Thanks very much. We haven't had any questions through on the Q&A yet, but please feel free to put them in as we go on. I just had a question. So this webinar is targeted towards international students. And Alpa, you touched on some of the assistance that we offer, whether it be employability, a maths cafe, those sorts of things. What sort of challenges do some of our international students experience, and how do we help overcome that? Like, do you get students coming to you directly with challenges that they have, kind of, I guess, being in a new country or learning a new academic system? Is there any specific ones that spring to mind that we help support our students with?
Do you want to say? I think I feel like you will say something.
Okay, yeah.